Hi all, in this video we'll be solving the maximum product subarray problem, that is problem number 152, and which is a medium level problem. So first let's look at the question. The question is, we'll be given an input array which can contain positive, negative and the zero values, right? That is the elements can range from -10 to +10. Now the question is, we need to find a contiguous non-empty subarray within the array that has the largest product and return the product. So we need to find a non-empty subarray, that is, at least there should be one element in the subarray we are considering, and also it must be the product of its element should come out to be the largest product, right? Now if the array was containing only positive values, we can say that when we multiply each elements, we'll be getting a bigger value, right? So as we multiply, we'll get bigger and bigger values, right? But in this scenario, we'll be having negative and zeros also along with the positive elements of this array. So one issue is, if at all we are multiplying elements, and when we multiply a big number with a negative number, that big number will turn out to be a negative number. That is maybe the least possible value we can find so far, right? And also if we move forward, that is let's say we are taking that negative number and we move forward, and then again if we find a negative number, that will comes out to be a positive number, right? That will be the largest positive number we can get, right? If two negative numbers are there. That is the second case. Now there is also one more case, that is we can say third case, that is 0, right? So in the array, if 0 is there, what will happen is, the moment we multiply the previous result with that 0, then all the value so far calculated, that is all the product we have considered so far, will become 0, right? So 0 can actually become a stopper. Like let's say if we have a big array and we are multiplying each element, at some point when we encounter a 0, we can say that by multiplying with 0, if at all we were having a big positive number, that will become 0, simply because we just multiplied it with 0, right? So let's see how we can solve this problem. The approach will be, we'll be solving this in linear time, that is of n time, that is we'll be iterating through the entire array first, that is we'll be iterating the entire input array, and from the beginning till the end, what we'll be doing is, we'll see what is the maximum positive product we can get, and also what is the maximum negative product we can get. That is, during each iteration, at every element we'll see we'll store it, okay? We'll store the value, that is what is the maximum value and what is the minimum value, that is the most positive and most negative value will be stored. That is because as I mentioned before, if there are two negative numbers, then we can say that, like if we multiply two negative, we will get positive, right? So let's say at index 2 we found a negative number, so that becomes a negative number. At that point we may think that that is a number below 0, so that can be a maximum product. But later on, if we find another negative number, let's say -1 or something, so when we multiply the previous negative value with this particular -1, then that becomes a positive number, and sometimes that may become the largest possible product, right? So we don't know in future what can happen. That's why we'll be storing maximum positive and maximum negative numbers during each iteration. Okay, so let's go to the code and see. Here let's say yeah, and again this can be solved using dynamic programming. So the idea is for the first element, that is let's consider scenario like we are the given input array is of length 1, that is only one element is there. So in that case, what can happen? We need to return the maximum product, right? If there is only one element, we can return that only, right? And in the question it's given that it should be non-empty subarray, so at least one element should be there. So even if we get an input array with negative number, that is one element which is a negative number, we cannot return an empty array, because the result, what we need to consider should be a non-empty subarray. Okay, so in the base case, we need to at least return the product of one element. Okay, so what we can do is, initially we can have a dp array, and it can be filled with 0. Yeah, let it be 0, and 0 times, and what is the length of array? N equal to len of nums, and the size of the dp array will be n. Okay, so here we have initialized. Now let's see what's the ask. So the ask is to return the maximum product, right? So we can say mx prod equal to, so we can say maximum product equal to yeah, anyway we need to return at least one element, right? So we can set it to the first element, nums of 0 for now. Okay, anyway later we'll see, we'll be using a iteration, and inside the for loop, anyway this variable is going to get updated, and the actual result is going to be assigned to this variable. So at last we need to return this max prod. Okay, so we have this dp array, and yeah, and we have a base case, right? Dp of 0, that is let's say the base case be there is only one element. If there is only one element, then what we'll do, we'll just return a nums of 0, right? Yeah, and nums of 0, correct. And I told you, right, there can be possibility that a negative number can become positive late in the future. So we need to store two items in dp. Okay, one is maximum positive, and one is maximum negative value we have got so far. So in Python we can use a tuple to store this. Okay, we'll use a tuple that contains max positive and max negative. Okay, so we will be storing tuple inside this dp array in this format. So what can be the maximum positive? Like dp of 0 means the base case, that is for if there is only one element, then we know that maximum positive can be that number only. We don't have another option to multiply with. So in that case we'll give nums of 0, and also the same with max negative. At this stage the maximum negative is also nums of 0, that is the first element. Now that is done. Now yeah, now we need to keep on iterating. Now anyway we got the base case. Now we can start the iteration from the second element, that is index 1, from index 1. So for I in range 1 to n minus 1, we'll loop. Okay, so we need to find two things. One is what will be the maximum positive value, how we can, like there are few cases. Okay, let me write it. Okay, one second. There can be maximum positive equals maximum positive equals. So let's say we are at index 5. Okay, now either we can choose that particular value, that is the value which is at index 5, right? That is one option. If that is the maximum positive we can get. Okay, that is one option. Or else we can multiply it. That is we are taking the product, right? We can multiply that particular value with a previous maximum value. That is, if we are considering the array from a previous indexes till this index, then we can try to multiply this particular index with a previously calculated maximum positive value. Okay, now that will give again a positive value only, because positive into positive will give a positive value. That is one option. Okay, now again there is a chance that if in case the current element is a negative element, if we multiply this current element, that is we are considering at index 5, right? At index 5, let's say we are multiplying this element with a previously calculated most negative element. That is, from previous indexes we have calculated some negative value which we have stored. Okay, in DP array we have stored it here, right, in the form of tuple maximum and max positive and max minimum. So if we multiply a negative number with a previously calculated negative value, we'll get a positive value, right? Even there is a chance that this can be a bigger number. Okay, so we need to consider 3 cases here. So that will be, one will be we'll take the current element, that is during the iteration at which element we are at, we'll choose that alone. Okay, this is again, this is we are finding sub array, not subsequence, so it needs to be continuous, right? So that's why these are the options available. One is we'll consider that particular element alone. Okay, that will be nums of I. Okay, that is one option. Then we have another option. Another option would be we'll multiply this one, nums of I, into a previously calculated maximum positive, right? That will be dp of I minus 1 of in dp we are storing it as a tuple, so we need to use indexing to access. This is the maximum and the second one is the minimum. Okay, so here we need to use maximum, so 0 index, that will access the tuple's first element, this one. Now also another option is nums of I will be multiplied with dp of I minus 1, which is, and also in this case we are trying to multiply with a maximum negative which is stored in the index 1 of this tuple, right? So index 1, that is one option. Okay, these 3 are the options, and among these 3 we need to take the maximum, right? We are considering first the maximum positive, so we need to take the max of these items. And also again we need to consider the minimum. We need to calculate the minimum what is it called, the maximum negative number also, and store it. Okay, because in the future sometimes if there is a negative value, that negative value multiplied with this particular value can give a bigger number. Okay, so we are continuously iterating, like we are finding a sub array which will give the maximum, right? So we need to have a min as well. Okay, max negative as well. We'll try to get the max negative value. Okay, and in this case it should be minimum. We'll consider the minimum we can get from it. Okay, that is the most negative we'll try to get. Okay, now we have these 2 items. Yeah, so we can store it in dp of I equal to tuple, right? We are storing it as tuple, that is max positive and max negative. Yeah, yeah, correct. And yeah, so at each iteration we are calculating this dp of I. Okay, so also at last we need to return is maximum product, right? So during each iteration we'll check whether whatever we have found just now is a better option, better result, that is a greater product or not. If so, we'll assign it to max product, mx prod variable. mxprod equal to max of mxprod comma the currently calculated value dp of I. If at all a dp of I is a better option, that will be stored in mxprod at this iteration. Okay, so it goes on till the end of the array linearly, and once it becomes exhausted, once the looping is completed, it exit from the loop, and at last we'll be returning the mxprod. Yeah, I think that's it. Let's try running it. Sorry, I just, okay, yeah, I stored it in an array, so we need to we are storing it as a tuple, right? Like this, tuple max positive and max negatives. Yeah, so let's try running it. Yeah, sorry, again I'm trying to compare it with a tuple here, so we need to have the first one, right? That is, we'll always be checking whether the max prod is can be updated with a better value, that is the first one, max positive. Yeah, again this can be replaced with, instead we can check with max positive, right? Max positive. Let's try running it. That works, and let's try submitting it. Yeah, it's working fine. Yeah, so see you in the next video. Bye.